Welcome students. I welcome you all for the subject mechanical behavior of engineering materials. So we'll start with the introduction of unit 1. Before we go in depth into the subject, we will see the historical perspective of this subject, why we have to study this subject. So we know that materials are very important in the development of human civilization. In respect, their names are associated in history, example Stone Age, Bronze Age, Iron Age, etc. Now you know that we are in the Iron Age because iron plays a major role in almost all our day-to-day activities. So with the time, human discovered new materials and also techniques to produce known materials. This is an ongoing process of coming centuries, that is, there is no end in sight. So the purpose of the study of mechanical behavior of materials is to select the materials for the purpose specified, to study the properties and behavior of the materials. What is mechanical behavior? So mechanical behavior is nothing but the response of the material on application of the load. So if you see the stress strain diagram, okay, if you apply the load on the material, first the material will be subjected to elastic deformation. For example, rubber and polymer are subjected to large elastic deformation. After the Hooke's law, after the material obeys the Hooke's law, that is stress is directly proportional to strain, the material starts to deform permanently, that is called as plastic deformation. So the next stage is plastic deformation, where the material cannot regain its original position. So the plastic or permanent deformation occurs on crossing a threshold value. The third stage is a fracture, when the material reaches its ultimate tensile strength, where it cannot able to withstand further load, then it starts to lose its strength and slowly it starts to fracture. So these are the three general stages in a material when the material is loaded. So if you want to select a high stiffness material, the parameter you should look is the modulus of elasticity. If you want to select a high strength material, the parameter you look is sigma y, that is the yield strength, and sigma UTS, that is ultimate tensile strength. So if you want to select a material to sustain long life without fracture, the parameter you look is the fracture toughness. It is abbreviated as KIC. Right, now what is material science? So you can see this triangle. Okay, so material science can be defined as a science dealing with the relationship that exists between the structures and the properties of the materials, which are useful in practice of engineers profession. So you can see the basic components and their interrelationship. Okay, first you have to study the structure of the material. So the structure of the material defines the property of the material. Okay, so after knowing the property of the material, we can process the material. Okay, after process the material, we have to check the performance of the material. So these four parameters are related to each other. We will see these things in depth when we further proceed into our subject. Okay, now coming to the properties of the material, there are several properties of the material. Okay, you can see that there are the categories of the properties of grouped into 6 categories, like mechanical, electrical, thermal, magnetic, optical, and deteriorative properties. There are several properties. Okay, these 6 are grouped here. Apart from this, there are some physical properties, chemical properties are also, which plays a major role. Okay, you know that all solid engineering materials are characterized for their properties. So the engineering use of the materials is reflection of its properties under conditions of use. Each materials possess a structure, the relevant properties, which is dependent on processing and determines the performance. Okay, right. Next, why study the properties of the material? Since there are thousands of materials available, it is almost lack of materials. Okay, so when this PPT was prepared, it was thousands of material. Now it is lakhs and lakhs of material, because research is going on daily. Okay, on day-to-day basis. Okay, if you see that at this hour, 4 or 5 materials are being discovered. Okay, it is almost impossible to select a material for a specific task unless otherwise its properties are known. So there are several criteria on which the final decision is based on. So there are less chances of material processing optimal or ideal combination of the properties. Okay, so we cannot tell that this is an ideal material. Okay, so because the properties changes with addition of each and every composition of the material. So there is no optimal material or ideal combination of the material. That's why there is no end to the materials research. A need to trade off between the number of factors. are there when we are doing some research on the materials. For example, you can see two properties called as strength and ductility. Okay, these are all the controversial properties. Okay, if you improve the strength, the ductility of the material decreases. If you increase the ductility of the material, the strength decreases. So this is a controversial properties, but nowadays research is going on in order to improve both the strength and ductility of the material. Unless the material possesses good ductility, we cannot able to change its shape. Okay, so the ductility is quite equally important when we consider the strength of the material also. So normally material processing strength having limited ductility. In such cases, a reasonable compromise between two or more properties are important. How we have to improve the ductility of the material? By regaining its strength. Okay, that is one problem of research. A second selection consideration is any deterioration of material properties during service operation. That also we have to look into. If you are adding some alloying element into this, okay, so there is a limit for adding the alloying elements that we are going to discuss in our future subjects, future units. Okay, that I'll come back into that. So when we want to improve the property of the material, we have to add more and more alloying elements. Okay, so the more and more if you are adding the alloying elements, the cost of material processing goes on higher. So finally the overriding consideration is economics. Okay, so if you want to give a good material which possesses very good strength and ductility, the processing cost increases. Okay, so if your processing cost is increases, you cannot sell your product. Okay, so that also you have to trade off these two parameters into account. Okay, so if you are giving a material with a good strength and ductility, you have to give it in an affordable cost to the society, then only your product will be sold. Okay, at a very good then only there will be a very good demand to your product. Okay, now coming to the classification of the materials, there are three basic group of solid engineering materials, okay, based on the atomic bonds and structures. We can classify the materials based on their atomic bonds and structures. They can be broadly classified into metals, ceramics and polymers. So these are the major group of materials. So the classification can also be done based on either properties like mechanical, electrical, optical, and also based on the areas of applications like structures, machines and devices. So further we can subdivide these groups according to the present engineering needs like composites, semiconductors and biomaterials. So what are metals? Metals are characterized to non-localized electrons, that is metallic bond between atoms, that is electrons are not bound to a particular atoms. So they are characterized by their high thermal and electrical conductivities. They are opaque, which can be polished to high luster. The opacity and reflectivity of a metal arise from the response of the unbound electrons to electromagnetic vibrations at light frequencies, and the metals are relatively heavier, strong yet deformable. You can see there are several metals available. Examples: steel, aluminum, brass, bronze, lead, titanium, etc. There are several materials are available. Several metals are available. So among which these are 5 metals are listed out here. Okay. Next category of materials is called as ceramics. Okay, you can know ceramics. These are very oldest materials. Okay, they contain both metallic and non-metallic elements, characterized by their higher resistance to high temperatures and harsh environments than metals and polymers. Normally, ceramics are brittle in nature, so they are very good conductors. They are very poor conductors of electricity, but they play a major role in as an insulator. They are very good insulators to passage of both heat and electricity. They are less dense than most metals and alloys. They are harder and stiffer but brittle in nature, as I pointed out earlier. They are mostly available in the form of oxides, nitrates and carbides of metals. Okay, for example, silicon carbide, okay, nitric oxide, okay, silicon carbide, silicon nitride, like that. So wide range of traditional ceramics are also available in the form of a clay, silicate glass, cement, etc. to advanced materials like carbides, pure oxides and non-silicate glasses. Okay, so the common examples for ceramic materials are glass, porcelain, minerals, etc. Coming to the polymers, commercially they are called as plastics. Okay, they are noted for their low density, flexibility and use as insulators. Okay, even now we are using polymers in many of our day-to-day applications. The only drawback in the polymers is they are non-degradable. Okay, they won't degrade, okay, even when we bury in the ground. Okay, so the only thing is we have to destroy it by burning it, okay, but even if you burn that one, okay, it produces harmful gases, okay, harmful gases that is that will pollute the atmosphere, okay. That is why even though polymers possess lot of properties, their use is less in several applications. Even then, now the research is going on in order to decompose these kind of polymers, okay. That's why we are calling it as a thermoplasters and thermosetting polymers, like that, okay. Nowadays a lot of advanced research work is going on in order to decompose these polymers for several after its use, okay. So most of the polymers are of organic compounds, that is based on carbon, oxygen and other non-metallic elements. So they consist of large molecular structures bonded by covalent and van der Waals forces. They decompose at relatively moderate temperatures, at the temperature range between 100 to 400 degrees centigrade. The common applications is packaging industries, textile industries, biomedical devices, optical devices, household items, toys, etc. So the commonly used polymers are nylon, Teflon, rubber and polyester, etc. Right. Coming to the next range of materials is composites. You know, nowadays composites play a major role. Lot of research work is carried out in the composites. The most advantages of composite is low weight to strength ratio, okay, high strength to weight ratio, low weight but it possesses high strength, okay. So in the olden days we used teak wood, okay, for our main doors and all, okay. Nowadays we are replacing this teak wood in the form of composite materials, which possess the same strength that teak wood possesses, okay. Because the another drawback in obtaining this teak wood is okay, the cost, okay, because the availability of teak wood is nowadays very less, okay. The cost of obtaining that is more, okay. So nowadays we are replacing these kind of teak woods for our commercial applications, that is household applications, in the form of composites, okay. So composites consist of more than one kind of material, that is they are generally called as a tailor-made materials, made to benefit from a combination of best characteristics of each constituents, okay. You know that polymers composites consist of the major constituent matrix, and it is reinforced by means of a reinforcement. That's what it is called as a tailor made material. So they are available over a wide range, from natural wood to synthetic fiber glass. So many are composed of two phases, as I said earlier. One is a matrix which is continuous and which is surrounded by the other, called as a reinforcement, that is dispersed phase. So they are classified into many groups depending on orientation of phases, such as particle reinforced, fiber reinforced, and depending on the matrix they are classified into metal matrix, polymer matrix and ceramic matrix. The common examples of composite materials are cement, concrete, fiberglass, special purpose refractory bricks and plywood, etc. So the next range of materials is semiconductors, okay. Semiconductors mostly play a major role in electrical field. Their electrical properties are intermediate when compared with electrical conductors and electrical insulators. These electrical characteristics are extremely sensitive to the presence of minute amount of foreign atoms. So they found many applications in electronic devices over decades through ICs. You know that integrated circuits are used, okay, in our computers and other electronic devices, such as mobile phones, etc. It can be said that semiconductors revolutionized the electronic industry for the last few decades. You all know that. The next category of metals are biomaterials. Nowadays the research on biomaterials are also advancing, because we are replacing the human parts, okay, by means of the biomaterials, biocompatible materials, okay. So they are used for replacement of damaged or diseased body parts. The primary requirements for replacing the biomaterials into a human tissue is that must be biocompatible with the body tissues. It must not produce any toxic substances. So the important material factors which we have to take into mind is it should be able to support the forces, low friction and wear, density and reproducibility, and the cost of the material. So all the above materials can be used depending on the applications. A classic example is hip joint. We are nowadays replacing the hip joint with a biocompatible material, okay. So what are biocompatible materials? There are several materials. Even stainless steel is a biocompatible material, okay. So these are the several categories of the biomaterials, like stainless steel, cobalt 28 chromium and 6 molybdenum, and beautiful material titanium 6 aluminum 4 vanadium, which plays a major role in all biomaterials applications, and ultra high molecular weight, polyethylene, high purity dense aluminum oxides, etc. Right. Then the next category is advanced materials. They can be defined as the materials used in high technical devices, that is, which operates based on relatively intricate and sophisticated principles. Examples: computers, air spacecrafts, electronic gadgets, etc. So these advanced materials are either traditional materials with enhanced properties or newly developed materials with high performance capabilities. Thus these are relatively expensive. The typical applications includes integrated circuits, lasers, LCDs, fiber optics, thermal protection for space shuttles, etc. The common advanced materials are metallic foams, intermetallic compounds, multi-component alloys, magnetic alloys, special ceramics, and high temperature materials, etc. Okay, so what is intermetallic compounds? They are nothing but the reactive materials. Okay, so if you are adding one material into the other, if it is not dissolving, instead of dissolving, it is reacting with the other materials, then we can get an intermetallic compound. Okay, so like silicon carbide. Okay, like that, silicon carbide, silicon nitride. These materials are like intermetallic compounds. Nowadays metallic foams also plays a major role in the research field. Okay, so because of its lightweight, high strength. Okay, so we are using these metallic foams in several applications, right? The next, future materials. Okay, there are future materials because day to day research is going on, improving, so we can get newer materials. A group of new and state of art materials now being developed and expected to have significant influence on present day technologies, especially in the field of medicine, manufacturing, and defense. So these materials are called a smart and intelligent material system, which consists of some types of sensors which detects an input, and an actuator performs responsive and adaptive functions. Okay, you can see the actuator. What is an actuator? They may be called upon to change the shape, position, natural frequency, mechanical characteristics in response to changes in temperature, electrical magnetic field, moisture, and pH values, etc. Okay, so these materials obeys based on these characteristics. Okay, like temperature. Okay, based on the temperature, the material properties changes. Okay, it behaves differently with certain electric and magnetic field. Based on the moisture, it will change its characteristics, and based on its pH value, it can change its characteristics. Okay, so there are 4 types of materials used as an actuators, like shape memory alloys, piezoelectric ceramics, magnetostrictive materials, magneto-rheological fluids. You can see a common application of the shape memory alloys. We are using specs, no? We are using the frames of specs. Okay, when you bend it, okay, after some time you can see it will come to its original position. Okay, that is a application of the shape memory alloys. Okay, so there's other materials which are used as sensors are optical fibers, piezoelectric materials, electromechanical systems, that is MEMS, etc. Right, so the typical applications are, by incorporating the sensors, actuators, and chip process into a system, researchers are able to stimulate biological human-like behavior. Nowadays you can see a lot of robots are coming out. Okay, so these kind of sensors and actuators play a major role in the robot research. Okay, fibers for bridges, buildings, and wood utility poles. They also help in fast moving and accurate robot parts, high speed helicopter robot blades, and actuators that control chatter in precision machine tools. Okay, so it can reduce the chatter wear in the precision machine tools, and small microelectronic circuits in machines ranging from computers to photolithography prints. Okay, you can see where the photo lithography prints. Okay, this is one of the additive manufacturing techniques nowadays we are using, and health monitoring, detecting the success or failure of a product. So modern materials needs. Now we are almost into the conclusion of the introduction part. Okay, so for example, engine efficiency increases at high temperature, which requires high temperature structural materials. So the use of nuclear energy requires solving problems with the residue or advance in nuclear waste processing. So we have to select the materials based upon the necessity and the need. For next example is hypersonic flight requires materials that are very light, strong, and resist high temperatures. And optical communications requires materials like optical fibers that absorbs light negligibility. And civil construction field, you need materials for unbreakable windows, and structural applications needs material that are strong like metals and resist corrosion like plastics. Okay, so with this we are coming into the introduction part, and we will move on to the revisit to the fundamental requisite of this subject. These are the basics which you should know before studying the mechanical behavior of the materials. Okay, so you all are aware of the bonding. Okay, you would have studied this in your school level itself, the bonding. Okay, bonding of the materials, the structures, atomic structures, atomic bonding and all. Okay, so the chemical bonding, you know what is a primary bond? There are three types of bond existing in materials: ionic bond, covalent bond and metallic bond. Okay, and these are generally called as a primary bonds. You can see this example, sodium chloride. Okay, it's a primary bond. Okay, you can see sodium chloride. And secondary bonds are van der Waals forces, hydrogen bonding, like this. You can see this illustrated in the diagram. Okay, where free electrons from outer shells of the metal atoms are present in the arrangement of the lattice structure. Okay, so the next another example is an oxygen molecule, which is given here. Okay, so how you can see the free electrons surrounding the shells of the metal atoms. Okay, now you can classify the materials like this based on the bonding, crystallinity, strength and conductivity. So the metals and alloys, okay, metals and alloys consist of a metallic bond. Their crystallinity, they are having a crystalline structure, the strength is high, the conductivity is also high. If you go to ceramics, they are having a covalent or ionic bond, and their crystalline structure are in the form of they are available both in crystalline and amorphous structure. The strength is high, but they are brittle in nature. Already I pointed out when we are discussing about ceramic materials, they are possessing high strength but brittle in nature. The conductivity is very low. Coming to the polymers, they are having a covalent structures. The crystallinity structure is an amorphous structure and their strength is very low, but the conductivity is also very low. Okay, coming to the composite material, you know the composite material consists of the matrix and reinforcement. Okay, so and also the structural materials, functional materials and semiconductors possess the metallites, ceramics and polymers. Nanomaterials consist of the consist of the metals, ceramics and composites. Biomaterials, once again metals, ceramics and polymers. All these kind of metals can be used in the bio applications. And smart materials like metals, ceramics and polymers. Okay, so now we will switch on to the next topic, that is a phase diagram. Okay, what is a phase? Okay, anything which is distinct is called as a phase. Okay, quickly we will go into the introduction part, then we will go into our detail into our subject in the forthcoming video. Quickly I will complete this title. So what is a phase? Okay, a phase is nothing but anything which is distinct is called as a phase. For example, if you have a cup of hot coffee, okay, a cup of hot coffee in your hand now. Okay, you place that hot cup of coffee in the table. Okay, you leave it for few minutes. Okay, for example 2 to 3 minutes. Okay, you can see a layer will be formed over the surface. Okay, so what is that one? That is a phase transformation that occurs. Okay, so that is the phase change that takes place. Okay, anything which is physically distinct, okay, it's called as a phase. Okay, so in order to form a phase in the materials, you should be aware of what is a solution, what is a solute, what is a solvent. Okay, how to mix that one, those things. Okay, you know what is a solution? A solution is nothing but a homogeneous mixture composed of two or more substance. Right, now I am taking a glass full of water. Okay, I am taking a teaspoon full of sugar, I am stirring it. Right, so which one is the solute and which one is the solvent? The major component is called as the solvent and the minor component, that is the sugar, is the solute. Okay, so now if I am mixing it, then I will get only one liquid. Okay, that is the sugar particles dissolved in water, that is called as a solution. That is, solution is a homogeneous mixture composed of two or more substance. In such a mixture, a solute is dissolved in another substance known as a solvent. A common example is a solid such as salt or sugar dissolved in water, a liquid. Okay, gases may dissolve in liquids. That's another example. For example, carbon dioxide or oxygen in water. Okay, you can see that you are having a Pepsi. Okay, Pepsi or a Coca-Cola. Okay, now you are opening it, suddenly you can see some gases are coming out. What those gases? Carbon dioxide. Okay, is being mixed with the water. Liquids may dissolve in other liquids. Okay, all solutions are characterized by interaction between the solvent phase and solute molecules or ion that results in net decrease in free energy. Examples of solid solution are certain minerals and polymers containing plasticizers. Okay, so the ability of one component to dissolve in another compound is called as a solubility. Okay, now to better explain the solubility, okay, now I told an example. I am taking a glass full of water, I am mixing 1 teaspoonful of sugar. Now what happens? It dissolves, the sugar dissolves in the water. I am taking another teaspoon, I am putting it in the water, I am mixing, stirring it. Okay, you can see the second teaspoonful of sugar also mixes or dissolves in the water. Like that I am continuing the process. Okay, up to 3 to 4 teaspoon it will be dissolving. Okay, after that what happens? The solubility limit is reached. Okay, now you can see even if you stir more, okay, you cannot the sugar particles will be settling down instead of dissolving in the water. What is the meaning for that one? The solubility is limit is reached. Now I want to increase the solubility of the water. What will you do? Normally you will heat it. Okay, now after heating the water, okay, when the temperature of the water rises, okay, now I am mixing more amount of sugar, the sugar gets dissolved. Okay, that is super saturated solution. Okay, now you know what is solubility, now what is super solubility. Okay, so like that if you are mixing more and more sugar, then the liquid becomes a form of a precipitate. Okay, you can see that sugar precipitate normally we use for making some sweets. Okay, we can see this in our house for when we are making sweets, we will do this one. Okay, so this is called as super saturated solid solution. Okay, now after when the temperature is going on rising, there is a limit, okay, where the super saturation limit is also reached, after which we cannot add more number of sugar into this. Okay, then you will get a precipitate. Okay, so the ability of one component to dissolve in another component is called as a solubility. The physical properties of compounds such as melting point and boiling point change when other components are added. So the solubility of a solute is the maximum quantity of solute that can dissolve in certain quantity of solvent or quantity of a solution at a specified temperature. The main factors that have an effect of solubility are the nature of the solute and the solvent. While only 1 gram of lead chloride can be dissolved in 100 grams of water at room temperature, okay, then 200 grams of zinc chloride can be dissolved. Okay, that the nature of the solute and the solvent depends on the type of the solute and the solvent. Okay, the great difference in the solubility of these two substances, the result of differences in their nature. Now coming to the temperature, generally an increase in the temperature of the solution increases the solubility of a solid solute. We have discussed that one. A few solid solutes, however, are less soluble in warmer solution. For all glasses, solubility decreases as the temperature of the solution rises. So why we are discussing all these things? You are going to do some research on the materials. Okay, when you are doing some research on the materials, you have to mix several combination of the materials to give a better property. Okay, already in the beginning I told the structure of the material changes the property. Okay, now if you are taking a solute atom and a solvent atom, the structure of solute and solvent, okay, how this should be, that we will discuss in the forthcoming classes. Okay, what are the rules for making these kind of solid solubility and all. Before that we will discuss all these things, like what is the effect of the temperature, pressure, etc. Okay, right. So for all gases, solubility decreases, the temperature of the solution rises. So pressure for solid and liquid solutes, changes in pressure have practically no effect on solubility. For gaseous solute, an increase in the pressure increases solubility, and the decrease in the soda pop is removed, pressure is released, and the gaseous solute bubbles out of the solution. This escape of the gas from solution is called as a effervescence. Okay, you can see already I have told this one. Okay, now what is a phase? A phase or matter is a domain with a many body system within which relevant physical properties are uniform. So relevant properties may include chemical composition, crystallinity, and density, which do not reflect how the components are arranged in space. They may also include crystal structure, magnetic properties, etc. Right? Now we will discuss with this we will end our first session. In the next session we will discuss on the phase diagrams elaborately. Okay, so thank you all for your listening. Thank you.